Good day. Welcome to the third part of our discussion class on absolute convergence and tests for absolute convergence. Before watching this video, make sure na napanood niyo na yung second video on our discussion class. Katulad ng nabanggit ko sa first two videos, I have considered here the exercises given in Math 22 module, page 58. The instruction there is to determine whether the series is absolutely convergent, conditionally convergent, or divergent. So far, we are able to answer items A to B. At the end of the second video, I have asked you to apply the ratio test in letter E. So, sagutan natin yung letter E at tignan natin kung parehas tayo ng nakuhang solution. So, this is the infinite series given in letter E. Katulad ng sinabi ko, since m in here ranges from 1 to positive infinity, each term in our infinite series is non-zero. Thus, we can apply the ratio test. Let a sub n be equal to this one for all n. We can apply the ratio test in this infinite series since each term in this infinite series is non-zero. Applying the ratio test, we have to take the limit of the absolute value of a sub n plus 1 over a sub n as n goes to positive infinity. If this limit turned out to be less than 1, then we say that this infinite series converges. If this limit turned out to be greater than 1 or is equal to positive infinity, then we say that this infinite series diverges. However, if this limit turned out to be equal to 1, then our ratio test is inconclusive. Now proceeding with the solution, we replace a sub n plus 1 with this one, and the reciprocal of a sub n is given as this. Now I want you to look at the following. So in here, two n plus 2 factorial is just 1. So meron ka ditong 2n plus 2 factorial. This is just equal to 2n plus 2 times 2n plus 1 times 2n factorial. This one over here is just n plus 1 raised to n times n plus 1. Thus, this limit is just equal to the following. As you can see, you can factor out 2n factorial in here and 2n factorial in here. Thus, you are left with the following. The absolute value of the one inside is itself since n ranges from 1 to positive infinity. The limit of 2n plus 2 times 2n plus 1 over n plus 1 is just positive infinity. The limit of this is positive infinity. The limit of n raised to n over n plus 1 raised to n as n goes to positive infinity is just 1 over e. For this one, verify. So you apply what you have learned in Math 21 in order to look for the value of the limit of n raised to n over n plus 1 raised to n. So you recall some topics in Math 21. It will be seen that this limit is just 1 over e. Thus, you have here positive infinity times 1 over e. 1 over e is a positive number, so times positive infinity, you have here positive infinity. Thus, we have shown that this limit is equal to positive infinity. In return, by ratio test, we say that this infinite series diverges. And that's it for letter E. Parehas ba kayo ng nakuhang sagot? I hope so. Let's proceed with letter F. So you have the following. As you can see, itong buong ito ay naka-raise sa n squared. Again, as you can see, yung buong ito ay naka-raise sa n squared. If that is the case, you might want to apply the root test. Let a sub n be equal to this term for all n. Since this whole term is raised to n squared, we wanted to apply the root test on this infinite series. Applying the root test, we have to look for the limit of the absolute value of a sub n raised to 1 over n as n goes to positive infinity. Replacing values, before we replace values, let us recall that if this limit is less than 1, then we say that this infinite series converges. If this limit is greater than 1 or is equal to positive infinity, then we say that this infinite series diverges. However, if this limit is equal to 1, then the root test is inconclusive. Now proceeding with the solution, we just replace an in here with n over n plus 1 raised to n squared. So we have the following. So ang ginawa lang natin dito, i-replace lang natin yung value ni e sub n. Ngayon, yung n mo, nag-range siya from 1 to positive infinity. If that is the case, then the 1 inside is always positive for all n. If that's the case, then its absolute value is itself. So the absolute value of the 1 inside is itself. And if you raise it to 1 over n, you'll get the following. As you may recall, in item letter E, sabi natin doon, the limit of n raised to n over n plus 1 raised to n as n goes to positive infinity is 1 over e. I ask you to apply what you have learned in Math 21 in order to determine the value of this one. So this is just 1 over e. We have here 1 over e. Since e is approximately 2.71, it is greater than 1. So you have your 1 over some positive that is greater than 1. So the whole thing is less than 1. So we have shown that this limit is less than 1. So by the root test, we say that this infinite series is absolutely convergent. And this is our final answer for letter F. Let's answer another item. So we have here this infinite series. Okay. For letter F, as you can see, tapos na tayo dito, di ba? Okay. Dito na tayo sa letter G. For letter G, we have this infinite series. As you can see, n squared times arc cotangent of n is raised to n. As you can see, this whole thing is raised to n. Since that is the case, you might want to apply the root test. Let a sub n be equal to this term for all n. Since this term is raised to n, we wanted to apply the root test. So we apply root test on this infinite series. Applying the root test, we have to look for the limit of the absolute value of a sub n raised to 1 over n as n goes to positive infinity. Again, if it turned out to be less than 1, then we say that this infinite series converges. Absolutely convergent to be precise. If this limit turned out to be greater than 1 or is equal to positive infinity, then we say that this infinite series diverges. However, if this limit turned out to be equal to 1, then we say that root test is inconclusive. Now, let us replace an with this one. So what we did here is we replace an with this one. Okay, so our n here ranges from 1 to positive infinity. So n squared here is positive. Our cotangent of n, the value of our cotangent of n ranges from the values in the interval 0 to pi. So our cotangent of n is positive. Again, our cotangent of n has values from the interval 0 to pi. So our cotangent of n is positive. So you have here positive number raised to a positive number that is positive. So its absolute value is itself. And if you raise it to 1 over n, you get n squared times our cotangent of n. So you have the limit of n squared times our cotangent of n from as n goes to positive infinity. So you have this one. Okay. Notice that as n goes to positive infinity, n squared goes to positive infinity, and as uh, as n goes to positive infinity, our cotangent of n goes to 0. Verify. So you verify this one. Okay. So use your Math 21 skills. So the limit of n squared as n goes to positive infinity is positive infinity, and the limit of arc cotangent of n as n goes to positive infinity is 0. You have to verify this one using your Math 21 skills. Okay, so if you are dealing with an indeterminate form of type 0 times infinity, you have to move one factor in the denominator. So in this case, I have moved n squared in the denominator. So you have here r cotangent of n over the reciprocal of n squared. So we are evaluating the limit of this one as n goes to positive infinity. Now this is of the form 0 over 0. So we can apply the L'Hopital's rule. You'll get the following. And as you evaluate the limit further, you'll get positive infinity. So we have shown that this limit is equal to positive infinity. Therefore, by the root test, this infinite series diverges. And this is our final answer for letter G. So far, we are able to answer items A to G, and we are left with item H and I. I will leave these two items as an exercise. So you try to answer items H and I. For letter H, verify that this infinite series is absolutely convergent. And for letter I, verify that this infinite series is conditionally convergent. That's all for today's discussion, class. Thank you for watching. Bye.